In this video, we're going to look at redox reactions. Now, in order to understand redox reactions, we need to know what reduction and oxidation are. So, oxidation is the loss of electrons, while reduction is the gain of electrons. And when something is oxidized, then the other substance has to be reduced. The electrons have to go from somewhere to somewhere else. You can't have oxidation happen by itself. You can't have reduction happen by itself. If something is being oxidized, it means it's losing its electrons. Those electrons have to go somewhere, so the other thing has to be oxidized or reduced. So there's a couple different ways you can remember this. We have oil rig, where um, oxidation is loss, and rig is reduction, is gain. Another one that I've seen is Leo Sesger, like Leo the lion, if you will. So loss of electrons is oxidation. Gain of electrons is reduction. I don't care how you remember it. You can just remember that oxidation is loss and reduction is gain. Just use the one that is going to work for your brain. A redox reaction is going to happen when the oxidation numbers change during a reaction. And something you need to realize is redox is just reduction and oxidation. So sometimes you might see it as redox, where we have reduction and oxidation. So we have the oxidation numbers within our chemical reaction, and if they change during that reaction, then you know a redox reaction has happened. Now, one element is oxidized and it loses electrons, so its oxidation number is going to increase. One element is reduced. So that means it's gaining electrons and the oxidation number is going to decrease. Now, when this happens, you're going to get what we call our agents. So the reducing agent, whoops, the reducing agent is going to give away the electrons. And what that does is it causes the other substance to be reduced. Something you need to realize here is the reducing agent is actually oxidized. So the thing being oxidized is the reducing agent because it's being oxidized, so it is losing electrons, which is causing the other substance to get reduced. So that's why it is the reducing agent. The oxidizing agent is going to take the electrons from the other substance. So it's causing that substance to be oxidized. So in this case, the oxidizing agent is actually reduced. So the thing that's being reduced, meaning that it is gaining electrons, is causing the other substance to be oxidized. So that's why it's called the oxidizing agent. So oxidation numbers can be calculated for every single element within a chemical reaction. And this is very important. Each element in a chemical reaction can be assigned an oxidation number. And if the oxidation number of an element changes as a result of the chemical reaction, then that means a redox reaction has happened. Another way of saying that is the oxidation number on the reactant side is different than the oxidation number on the product side for an element. Now, this is important. It has to be that single element where the oxidation number changes. Also, it's impossible to have a redox reaction where the oxidation number of one element changes and everything else stays the same. Remember, if something is losing electrons, those electrons have to go somewhere, which will change the oxidation number of the other substance. So here are the ways, here's what you can do to identify the oxidation number of different substances. So the oxidation number of an element is always zero. So this is meaning that this is in its elemental state in the chemical reaction, right? So it's not bonded with anything else. Now, the oxidation number of a monatomic ion is the same as the charge. Now, oxidation numbers are written, let's look at an example. So oxide, which is O2 minus, the charge is equal to 2 minus. That's how we write the charge. The oxidation number is -2. So oxidation numbers are always written with the charge followed by the number. All right, so that's how we differentiate between a charge on an element and an oxidation number. And the oxidation number sum, so if you add up all the oxidation numbers in a molecule or compound, then it needs to add up to the overall charge of that compound or molecule or species. So if we have nitric acid, HNO3, there's no charge here, it's not written, so all of the oxidation numbers need to add up to 0. For phosphate, the charge on phosphate is -3, has a 3 minus charge, so the oxidation numbers need to add up to -3. Fluoride is always -1. Hydrogen is always +1 unless it's bonded with a metal. Then it will be -1. We really won't see that in this class. So when you see hydrogen, it's going to be +1. Oxygen is always -2. Unless it is a peroxide, then it's going to be -1. So let's get some practice with this. In my first example, I have carbonic acid. I like to do the ones that are an always situation. So I know hydrogen is always +1, and I know oxygen is always -2. Okay, I know hydrogen is +1 because it's not with, there's no lithium. And then oxygen I know is -2 because we're not dealing with a peroxide. So if I have 3 oxygens and 2 hydrogens, I need to figure out what the charge of, or not the charge, what the oxidation number of my carbon is going to be. So I can set that up. I know that I have an oxidation of +1 for hydrogen, and I have two of those. And I have carbon. I only have one carbon, so I can just kind of solve for X, if you will. And then I have three oxygens, and the oxidation number of oxygen is -2. And this has to add up to 0. You'll notice that carbonic acid doesn't have a charge, so it needs to add up to 0. Now, when I solve for that math, I am going to get 4. So I have 2 plus x plus, it's 2 plus x minus 6. So if I solve for x, we're going to get +4. So carbon is +4. Now, if I put that up here, so hydrogen is +1, oxygen is -2. We're going to have three of these and two of my carbons. I have 2 plus 4 is 6, plus -6 is equal 0. So you can always double check your work. When you have a polyatomic ion, sometimes I think it's easier to figure out what the oxidation numbers are on the ions rather than trying to add everything up. So I am going to take three ammonias or ammoniums, and then I have phosphate. So hydrogen has to be +1, and my nitrogen, I need to identify what it can be. If I have 4 hydrogen, that's going to give me a total of +4. So my nitrogen has to be -3 in order for it to equal that +1. For my phosphate, I know that oxygen is -2, and I have 4 of them, which is going to give me -8. In order for phosphate to have a -3 charge, then my phosphorus has to be +5. So phosphorus is going to be +5. Oxygen is going to be -2. One of the biggest mistakes I see when doing these types of problems is people will say oxygen is -8. And that is not the oxidation number of oxygen. The oxidation number of oxygen is -2. The total negative we have from the 4 oxygen is -8, but that's not the oxidation number of oxygen. So just be very careful about that. In this next example, oxygen is going to be, I'm going to use a different color so we can differentiate. Oxygen is -2, and I have 5 of those, so that's going to be -10. Now, in order to come up with an oxidation number equal to 0 for the overall compound, I have 2 nitrogens, so those nitrogens have to be +5. And I can double check this. Nitrogen is +5, times 2 is +10. Oxygen is -2 times 5 oxygen is -10. In this next one, I know fluoride is always -1. I have 6 of them. So that makes it easy for me to figure out that the sulfur must be +6. In E, I have an ionic compound. So the monatomic ion, calcium, is a 2+ ion. So that tells me that calcium has an oxidation number of +2. The nitrate, NO3 minus, I'm going to have to figure out what my nitrogen is based off my oxygen. So my oxygen is -2, and I have three of them, which means I have an overall of -6. And in order to have a -1 charge, my nitrogen is going to be +5. So this does take some practice. Make sure that you get some practice on your own so that you can quickly identify the oxidation numbers of different elements. Where this is going to be important is identifying what is being oxidized, what is being reduced within a chemical reaction. So let's look at this example right here. The first thing I want to do is identify all of the oxidation numbers in my chemical reaction. What I like to do first is all of my elements I know have an oxidation number of 0. So that's easy to identify. And since I have aluminum, for example, going from by itself to a compound, I know that this has to be a redox reaction because if the oxidation number changes, then redox has to take place. Now, this is an ionic compound, so it's made of ions. And I know that monatomic ions, the charge is equal to the oxidation number. So I have oxygen in both sides. Notice, is oxygen being reduced or oxidized? No, it's not because the oxidation number does not change. Aluminum is a group 3 atom, group 3 element, so it is always going to have a +3 charge or a 3 plus charge, which means the oxidation number is +3. Iron has multiple charges, so I need to figure out which iron this is. My oxidation number for oxygen is -2. I have three of them, so it's going to be -6. I only have two iron, so that means the oxidation number must be +3 in order to make this a charge neutral compound. So I want you to notice that the oxidation of aluminum changes from 0 to +3. And the oxidation number of iron goes from +3 to 0. So I have two elements that are changing oxidation numbers, and oxygen stays the same. So if I want to figure out what is being oxidized, I need to look at what is gaining, or sorry, what is losing electrons. So iron goes from +3 to 0. So what's going on there? Is it gaining or losing electrons? Well, if we go back to one of our first slides, one element is oxidized and loses electrons, so the oxidation number increases. Iron goes from +3 to 0. That is not an increase in oxidation number, it is a decrease in oxidation number. Aluminum goes from 0 to +3. So that is an increase in oxidation number. So that must mean that the aluminum is being oxidized. Notice it's just an element that is being oxidized. It's not the entire substance, if you will. Now, when we look at what is being reduced, this is where we should see a decrease in oxidation number, and that happens with iron. So that is the iron 3 plus that is in our iron 3 oxide. Now let's look at the reducing agent and the oxidizing agent. Now, the oxidizing agent is what is causing something to be oxidized. And so it has to be gaining electrons. So my oxidizing agent is going to be my iron, but it's not just the iron. It has to be that entire compound. So it's going to be my iron 3 oxide. And that means the reducing agent is going to be the solid aluminum. Here are some problems you can do. It's very important that you understand that elements can have multiple oxidation numbers. So you can get some practice with determining the oxidation number on sulfur in each of these, and then chlorine on each of these. Here are three examples where you can identify the oxidizing agent, reducing agent, the substance being oxidized, and the substance being reduced. We have three different equations for you to practice with. Now, when you're going through and you're identifying types of reactions, notice that double displacement reactions are the only reactions where your oxidation numbers don't change, so they are not going to be redox reaction. Every other reaction we see in this class is going to be a redox reaction. So it's important that you make those connections.